and now I write new int or so this is what you suggested, right? Some of you have suggested this one, right? Hello.
Yes, sir.
So see the outcome of this. If I run this code, this is what is the output. So these are the errors that appears, and there is a serious error here. You see. So what to do now? Hello. So this is not going to work, right? This is not working. Are you getting me?
Yes, sir. Yes, sir.
So this failed. Any other option?
So we
Well,
could do
many
it
of you are.
separately.
Yes. This
So we
one. Which one?
could do it separately, sir. Like an R, new int R, and then new int C. I don't think that would work though.
So tell me something that will work. Will this work? If I write new int R into C, will this work?
Sir,
No, sir.
no, sir. So we have to do it in the row major format that you showed us, sir, the last day, sir.
What did I
Sir,
show?
R into C will work, sir.
It will work. Okay, let me check this
I
also.
think so.
So what we could do is that put it into a loop from for I equal to 1 to R, and then initialize dynamically allocate C data spaces for each iteration, and that way it would work, sir.
Okay, let me try this one also and see. So got the problem here? Here, if I try this one R into C, this also fails, right? Is it working? This also is not working.
Sir, then x would have to be a pointer to an
Sir,
integer, and we
it
would
will
have
be
to access
only
it using
one
the row
star.
major formula.
So that's the idea, right? So somebody was telling that okay, so this will not work. So why this will not work? Because here you see, so this is, so if I try this one R into C, what it means, you are basically trying to allocate uh, uh, you're basically doing this here. R into C means total, say if it is 2 comma 3, so 2 into 3 6, 6 into 4, total 24 bytes of space will be allocated, and the whole thing will be treated as a 1D array of boxes, right? But I want something like this. So this and this, there is a difference, right? So these are three
Yes.
boxes together within a green box, and it says that it's an array of, so total space is the same. So here you have got 2 into 3 6 boxes, 6 blue box. Here also have got 6 blue box, but here 3 blue boxes are grouped again in a green box. So this is something different, and this is what a 2D array means of 2 comma 3. So this is rather, it's a it's a 1D array of 6 integers, right? But what we want is a 2D array of 2 cross 3. Are you getting the point? So this is not achieved through this one. Is that fine?
Yes, sir.
Now this also failed. So what we know now, we can do it from the scratch, right? So we know that, so until unless you know the basics, you cannot, so you will be completely off. So there is no way of getting rid of the solution here in this case. So now you have to get back to the basics and know that, and we know that in case of arrays the elements are stored in row measure, right? So then if this is what is happening, then probably in the heap I can make a request, because if I know it's an array of say 2 cross 3, what do I do here is I definitely declare a pointer int asterisk p, that is fine. Now the point is, so this p will be somewhere where, so p is a statically allocated pointer variable, so p will be here, right, in the stack segment. Is that fine? Is that okay?
Yes, sir.
So now I would like to have allocation for 2 cross 3 integer array dynamically. So how do I do that? So the thing is, I cannot do it in a single shot. That is not possible. In a single new statement, this cannot be done. This will be too complicated. I mean, it is not possible, right? So what I do it in parts. What I do, I seek allocation of the space for the 0th row 0, and I seek allocation for the space for row 1 separately. And if I seek separately the space for row 1 and row 0, will they be contiguous to each other? Will there be just like this, one after the other? If you seek separately, so if say we two are friends, we would like to have a booking in a hotel. So if I have booked at the same time, I could have managed to have 2 consecutive rooms. But if I book once and you book sometime later, there is a very less chance that our rooms will be one after the other, right? Are you getting the point?
Yes, sir.
So the thing is, so this space for 3 integers in the row 0 here, and the space for 3 integers in the row 1, the space will be requested separately, right? So how to allocate? So the point is, who is going to store the base addresses here? Because now they are not contiguous. So it is not enough to store the address of this row 0 elements, or the 0th row base address. You have to also explicitly store the base address of the row 1 elements, because they are not contiguous now. So where to store it? Where to store it? Are you getting my problem? I mean, are you getting the problem?
Yes,
Are you
sir.
getting the problem? So the thing is, for this part, I have got allocation here, array of 3 integers, and separately I have sought space for array of 3 integers. This is row 0, this is row 1. Now the thing is, because they are not contiguous in the heap also, I have to store the base address of this and the base address of this. So where should I store it? P is just a single pointer, so I have to have 2 pointers. Of what type? I have to have separate 2 pointers, which will be pointing to this and will be pointing to this, right? Is that okay?
Yes, sir.
Hello?
Yes, sir.
Are you getting me?
So
Everybody getting me, or it's not?
Yes, sir. Yes.
So this also, you see, so this is dynamically allocated, and this is also, so this part is dynamically allocated, and this part is also dynamically allocated. But the thing is, this part also, because this is not P, so this part also need to be dynamically allocated, and this P should be pointing to this one, right? So what will be the type of the elements here? The type of the elements will be, they are storing the address of integers, right?
Int pointer.
So the types will be
Int pointers.
integer pointer. So now the address of this, the base address of this array, who can store it? A pointer to integer, right? So this P can store. So this is the actual allocation. So this whole thing will be in the heap, and this thing will be in the
Stack.
stack, right? So this P is already in the stack. So what we want is something like this. So this points to this, and this points to this, right? So if you would really like to code this part, or maybe this part, whatever you say, so this P, what this P points to, this P points to this one. Is that okay now? Is this okay?
Yes, sir.
Yes, sir.
So now so this is already statically allocated. So which one should be allocated first? These ones or this one? There are two types of allocation. One is for allocating the space for P, another is allocating the space for R0 and R1, the two rows. So which one should be done prior?
Sir, P.
The P, because without P, if you start allocating R0, R1, you will not be able to hold as addresses, right? So after this, see, after this int asterisk asterisk P, what do I need to write? So basically P should point to this one. So I can write P assigned. I would like to have the allocation for this. And let us assume that C out, C in, R and C. So I have in runtime I have got the number of rows and the columns, right? So first thing is, what is the size of the P? What is the size of the how many elements in P should be allocated? What is the size,
R.
or what is the type of the element? So what should I write here? The allocation for P. What should I write? New of
Int asterisk.
What is the type?
New int asterisk.
Int asterisk.
Asterisk.
Earlier you used new float. Now the type is int asterisk. So this is basically a type that you want to allocate. How many of the type I would like to allocate?
R.
R numbers, right? So like this. Is that okay? Is that fine?
Yes, sir.
Yes, sir.
So this basically, so this, if I call it as, say for example, this is A. So this is corresponding to the allocation of A, right? So now once this is ready, now we can we are free to allocate R0, R1, R2, R3, R4, as many number of rows I have asked for. Okay. Sorry, will it be R? Yes, it will be R, right? So what now? Next will be, so what will be the allocation for the ith row or this R0, R1? What will be the case now? So P0 or P1 or P2, Pi will be storing the allocation for. So how each of these rows will be allocated? What should I write? New of, what are the types?
Int.
What are the types?
Int, sir.
And how many numbers? Each of them?
E.
How many? Equal to the number of columns, right? Each rows they contain
3
equal to
numbers
the number
in
of
each
columns.
column.
So what should I write here?
C. C.
Is that okay? So now this need to be repeated for each and every row. So how many rows are there? Sorry, yes, how many rows are there?
2 rows.
R number of rows, say for example. Is this okay? So this part actually allocates. So this part actually allocates. Say this this is B. This is B. One by one, right? So the 0th row allocated and stored in P0. Then when I equals to 1, the first row, I mean the second row allocated, stored in P1. Then the third row allocated and it is P2, like that, all the R rows. Is that now okay? Everybody got?
Yes, sir.
So this much you have to write. So first thing is, this cannot be done in a single new statement. It is not possible. You need to go to the basics and you have to really enforce allocation row wise. I mean row major row wise allocation, and then binding the base addresses of the rows into another integer pointer, or I mean pointer to that element type array. So you have to allocate this array first and then go on the row allocations and assign it. So that is to be done. So if you do this, now the next question is, we have done, somehow we have managed to get the allocation, the required space, but let us see how it will behave. So if I write, say for example, P, if I write P plus 0, what does it mean? What is P now? Okay, just a minute. I think I have messed up this one. I should messed means I should not call it as P, because this is P, right? Got the point? So this is not P. So P is here. P is here. So this is not P. This is the array of integer pointers. So what is this size? This size is R. What is this size? This size is C. What is this size? This size is C. Is that okay? Is that okay till this point? Hello?
Yes, sir.
Are you still? Yeah.
Yes, sir.
So if I write P plus 0, what does it mean? P plus 0. So P means what? P is here, right? Or say P is here. So P plus 0, what is this? So P is this. P plus 0 means you are where you are. You are here. P is here outside this this box, right? So P plus 0 means you are still outside this box. Okay. So if I give a asterisk, what does it mean? What you can see now? You can see this part. P plus 0 is asterisk. Are you convinced? Hello? Simply P means the content. So you are here. Then P plus 0 means still you are here. P plus 0 asterisk means you are here. Is that okay?
Yes, sir.
So you are here means you can say that you are here, right? So if I write here plus 0, that means what? You are still here, right? Outside. That means you are here outside. In the memory you are here. But if I give another asterisk, then what does it mean? You are here inside, or you are here inside. Is that okay? Is that fine? You are simply P plus 0 here. Sorry. P plus 0, P plus 0 asterisk means you are here. P plus 0 asterisk plus 0, you are still here. P plus 0 asterisk plus 0 whole of asterisk, you are here. Is that fine?
Yes, sir.
Not convinced? Hello?
Yes, sir.
Yes, sir.
So what is this equivalent to? In the array notation, what do I write? So what does it mean? You are trying to access the 0th element, I mean 0th column element of the 0th row. Is that what we're trying to do here? So this means
Yes,
what?
sir.
So this is basically P00. Can we say this? Is this equivalent to P00?
Yes, sir.
Yes,
So if
sir.
I write here P plus 1, what does it mean? P plus 1 means, so P is here. P plus 1 means where you are? You are here. P plus 1 asterisk. Then where you are? You are here. That means you are here basically. P plus 1 plus 0. Where you are? You are still here. Did nothing. P plus 1 whole asterisk plus 0. Again asterisk. Then where you are? You are inside here. Right? What is this equivalent to? This is interpreted as the 0th column element of the second row. Right? This is the 0th column element of the second row, right? So this is equivalent to as
1.
so can you see this? So although we have done it in a indirect way, in a two-step, and although the rows are not physically contiguous, are they physically contiguous? No. But still, this notation of P00, P11 holds true. Got the point? After this, if you write P11, that means which element you are actually accessing? P1, 1. That means this one, or that means this one, right? So here, if you store here 5, this 5 will be stored here, or this 5 will be stored here, as you wish. I mean, as you interpret it. Is that fine? Is that okay? So this is important and this is critical. I mean, this is very simple, but I don't know whether you are getting things because there are very few voices that I can hear. So let me clear it out. Are you, have you got this part or?
Yes.
So what I want to
Yes, sir.
summarize from this is, although we have done it in this way, it appears to be a bit indirect way, but this is the only way to get a 2D array whose rows and columns are not known and which is known in runtime. It's a perfect runtime allocation. And if it happens so, even though we have done it like this, even though this is not physically contiguous the rows, but they are logically contiguous. Or in other words, if I write P00, this is equivalent to writing P plus 0 asterisk plus 0 whole asterisk like this. Or in other words, if I write Pij, this is equivalent to writing asterisk P plus I plus j whole of asterisk. If I write ampersand of Pij, this means actually asterisk of P plus I plus j. So this equivalence is still followed. So that means we have achieved the purpose of allocating a 2D array. So this allocation is not same as this allocation, right? The way, but it preserves the logical contiguity and still works. What is that drawback of this? The drawback is in terms of the space. How much of space is required if you go for a static allocation here? In a static allocation, what is the number of bytes that is required here? As you can see here, this is the r number of rows, each containing c. So r into c into 4, for example. And in this case, how much is wasted or how much is occupied here? You see, this is for the int asterisk. This is for the int, the row 0, the row 1, like this. So what is the additional space? So this is c into 4 into r, right? This and plus 4 into r, that is for this part, right? So this much is required space. Earlier the space was c into r into 4, but now you require this much of additional space, 4 into r, to get this flexibility. Is that okay? Hello?
Yes, sir.
Okay. So this is what it means. So I just go through it. So this is R and C. This is so first we do this allocation.
Sir, could you go to the previous slide just once, sir? I just needed to
Yes,
check one.
yes,
Okay, sir.
right. So when I come to this part in this yellow marker, so by the time, so this part is allocated, right? So in this case, let us assume that we have used r equals to 2 and c equals to 3. So this is done. So gradually see the allocation. Now we come to this part, the for loop, and we execute this one. So this part is done. So the row 0 is allocated, right? Row 0 is allocated. Not only that, but this points to this one. Okay. Now what happens? It takes the next value of k, again allocates this. So earlier it was pointing to this one, now this will be pointing to this one, right? Okay, but prior to that, when we allocated this part, so basically once we allocate this points to this one here, right? So when we do this, this was pointing to this and this part was done. So again this was true. Now this took place. Is that okay? Sorry. So this was this and this was this. So now when we delete this, which one will be deleted first? The 0th row will be deleted first. Okay. So this remains open. So this still points, but this points to something garbage. And the next time this gets deleted. So both points to garbage now. But this remains. And if I delete A, you see, delete A means this gets removed. Because that pointed by A will be removed. So this all of them they gets deallocated. Can you follow this? Can you follow this? Is that okay?
Yes, sir.
Yes, sir.
Yes,
So
sir.
here, so just I'll end it up within a minute. So the only point is here, if I write instead of this, if I write A plus I asterisk plus J asterisk, okay, so they are equivalent. So this and this both will work without any problem. Here also if I write A plus J asterisk plus A plus I plus J asterisk, this will work. Because no matter what the allocation took place, I have shown you that if I carry on the pointer arithmetic like A plus I asterisk plus J again asterisk, you are basically reaching the ijth element of that array. And if this happens, I can simply write it as Aij. So they are basically equivalent. So that's the essence that you know, that the pointer arithmetic the pointer arithmetic or the array notation still holds here. So we have truly been able to logically allocate a 2D array with flexible number of rows and columns in runtime, right? Okay, so there are other cases also. Okay, so the other case means if R is known, C is unknown. So there are 4-5 cases, and the one case it took almost an hour. So I don't know. So maybe so there are all these 3 cases here now. So meanwhile, can you try? I mean, I'm stopping the class today. So can you try the rest of the cases when R is known, C is unknown, R is unknown, C is known, and R is known, but C is different for different rows. So it's something like this. So it's an array of this type. What the point? So this is this case. Array of variable number of columns, each row. So I would ask you to try of your own these 3 cases. So I'll forward these slides after the next class. Let me see how many of you can try and come up with this. I have given enough hints through this first one. Is that okay?
Yes, sir.
Actually, these things should have been done in the C course itself. But okay. Any queries till this point?